Now that we've gone over some of the basics of Matlab, we're ready to start looking at some Raman spectra. So in this video, I'm going to be looking at this particular data set right here. It was taken in October and November of 2017. These are all measurements of blood lysate, and they were taken with a tornado spectrometer. So first, I'm just going to explain what all of these rows and columns mean. So starting in the second row, fourth column, all of these numbers here represent intensities of a Raman spectrum. And each row is a Raman spectrum itself. So this right here is one Raman spectrum. This is another Raman spectrum. And this is another Raman spectrum, and so on. The numbers to the left of each spectrum, so these three numbers, give you information about what you're actually looking at. So in the first column, we have the donor identification. So all these spectra that you're looking at right here are all from donor 11. If we go down, eventually we'll find donor 12. And in this particular data set, we have eight different donors. The second column represents the dose applied to the blood. So just forget about the 999 values for now. Basically, we see that from here to here, all of these spectra are control, so no dose has been applied. From here to here, these are all 1 gray. Here to here, we have 2 gray, and finally, here to here, we have 5 gray. And then the third column just represents sort of the order that the measurements were taken in. I like to call it the serial number. So all it means is that these measurements were taken first, and then these measurements were taken second, and these were taken after the second, and so on. The 999 here just represents a polystyrene measurement. So these Raman spectra to the right are not actually of any blood, just polystyrene, and we take these just for calibration purposes. Now finally, in this first row right here, we have the Raman shifts, disregarding these first 3 entries. So starting from here all the way to the end are all of the wave numbers, and under each wave number are the corresponding intensities. So if you're going to plot a Raman spectrum, you'll want to plot these values, along a single row against the Raman shifts that are right above. And that'll give you a Raman spectrum with intensity on the y-axis and Raman shift on the x-axis. Now, how can we get this data into Matlab? Well, there's 2 ways I like to use. There may be more, but these are just the 2 that I find work nicely. If I bring up the folder that contains the data, we'll see 2 different versions of the same data. So this CSV file right here is what we were just looking at in Excel. But there's also this special type of file called a .mat file. And these files are basically MATLAB variables preloaded with all the data. So .mat files, once you have them saved, are just kind of the easiest to access. One way would be to just simply double click, open with Matlab. We'll see this box right here pops up. All we have to do is just press finish. And we'll see in our workspace that we now have this data variable that contains all of the data we were just looking at in Excel. You can double click on this variable to see what data is actually held inside. So you'll see it looks identical to what we were just looking at in Excel. This can also be really useful for double checking row numbers and column numbers and seeing where the data you want is within the set. To close out of that, I'll just press the X here. Another way to load .mat files is through the command window. And to do that, first of all, you'd have to tell MATLAB to look in the folder where the file is located. So right now, MATLAB is looking into my LAMP folder, which is not where the .mat file is located. So in Windows, the way I like to do this, not sure how it works in Mac, but I go to the folder where I have the .mat file, click in this little search bar right here, copy all of that. And then what we do in MATLAB is we type in CD, which is short for change directory. And then within parentheses, put the location of the folder. Hit enter, and you'll see that the current folder is now updated. We're looking into the same folder that contains the .mat file. And all we need to do to load the data here is copy the name of the file. First of all, just clear all. Get rid of all the variables we have here just to show that this actually works. Then you type in load. And then again, in parentheses, put the file name. Hit enter. And as you can see, we get the data variable loaded in again. So let's say our data wasn't in a .mat file, and we only had this .csv file to work with. So how would we load the data from that? Well, I'm just going to clear all again. So in order to load data from a CSV file, the method I like to use is to use the DLM read function. I know there are other methods as well, but this is just the one I'm most used to. So the way we do that is I'll type in data equals. So basically I want to store all the data in the CSV file into this data variable. And we're going to call the DLM read function. Open the brackets and put the semicolon at the end to suppress the output. And so all we have to do is give the name of the CSV file. So I'm just going to copy paste all that. Remember to put it into parentheses. So that's the first entry of the function. The next input is we have to specify what's the delimiter. So what are all the values separated by? The values in a CSV file are all separated by commas. So within parentheses, again, you just have to specify that the delimiter is a comma. And then there's two more entries. These two entries just specify how many rows and how many columns you want to skip in the CSV file in order to get to the information you're actually trying to read in. So in this case, I don't have anything I want to skip. I want to load in all of these rows and all of these columns. So I'm just going to put 0 and 0. So this first entry right here corresponds to number of rows you want to skip, and the second entry corresponds to number of columns you want to skip. If your CSV file has, for example, some words at the top, well, MATLAB doesn't like to work with words if you try loading it in with DLM read. I'm not sure about other functions, but it'll throw an error. So yeah, we don't want that. In that case, you might want to skip some rows, but in this case, we're fine. So I'm just going to leave everything at 0, not skip anything, and just hit enter. So as it loads in this time, you'll notice it's taking a little bit longer. That's because it's actually going into the CSV file and extracting all those values. We don't have like a pre-made .mat file ready for us. So it takes a bit longer, especially this set of data is quite large. So anyway, as you can see, it's loaded in the data into this data variable. And that's how we import Raman Spectra into MATLAB. So next we want to actually plot our data. So what I'm going to do is actually create two new variables that split the data into two. So for the first one, I'm going to call it shifts, and I'm going to take just the Raman shifts from our data variable here. So to do that, I'm going to say shifts is equal to, and I'm just going to grab the very first row of the data variable. So if we open up the data variable by double-clicking on the variable in the workspace, we can go back and see what it looks like. So we have these three entries which we actually don't want because they don't actually represent any Raman shifts. So what we want to do is we want to take the first row and take all the values from the fourth column till the end. So to do that, in the row position, I'm going to put 1. And then in the column position, I'm going to specify I want the fourth column till the end. And that's something nice you can do in MATLAB. If you don't know how many columns you actually have, you don't have to go and count and say like, oh, I want column 3100 or something like that. All you have to do is specify end. So I'm going to suppress the output, hit enter, and you'll see that we get a shifts variable here. If I double click on that, we can see what that looks like. Basically, all we've done is just taken the Raman shifts from the full data set and put it into its own variable. Next, I want to make a variable called intensities. And in this variable, I want to store all of the intensities as well as the information of each Raman spectrum. So all of that is contained within the second row all the way till the end and all the columns. So to extract that data, I'm just going to go back to the data here. And for the rows, I'm going to specify I want the second row till the end. And for columns, well, I want all of them, so I'm just going to put a colon and then suppress the output, hit enter. And as you can see in the workspace, we get another variable called intensities that when we double click on, we see we don't have that, that first row with the Raman shifts and the 3 zeros right here. And that way it just makes it a little bit more convenient, at least in my workflow. All right, so first we can try plotting all of the Raman spectra here. See what that looks like. So what I'm going to do is type in plot. And then on the x-axis, I want the Raman shifts. So I'll put the shifts variable. Now on the y-axis, of course, I want the intensities. But one thing you have to be careful of is that these first 3 columns in the intensities variable aren't actually intensities. So we don't want to be plotting these against Raman shifts because that just doesn't make sense. And also in the shifts variable, we have 3,101 columns, while in the intensities variable, we have 3,104 columns. We want the number of columns to match, or else we'll get an error. So what we want to do is exclude these first 3 columns when we're plotting out the Raman spectra. So to do that, I'm going to call the intensities variable here and just specify we want all of the rows. So I put a colon in the row position and then just take the intensities from the 4th column till the end. So close that bracket, close the plot bracket, hit enter, and that's a lot of Raman spectra, so it might take a while to show up. And there we go. If I pull it over to the right, that's what we have. So this is what the raw Raman spectra look like. Obviously, we have some outliers here. If we press on this zoom button, we can actually drag a selection here and it'll zoom in. So there we go. This is just like thousands upon thousands of Raman spectra stacked on top of each other, so it looks really messy. We've got lots of cosmic rays here, lots of outliers, and this is all stuff that we deal with in pre-processing, so we'll worry about that in a future video. So that's what plotting all of the Raman spectra looks like. Let's say we want to plot a single Raman spectrum. So for instance, let's go into our intensities here. And let's say we want to plot this one right here, the very first Raman spectrum of donor 11. So we need to specify which row and which columns we're trying to get that spectrum from. So in this case, it starts on the 4th column and goes to the end, just like previously. But this single spectrum is only found on the 22nd row. So in order to plot out that single spectrum, I'm going to type plot again, put shifts on the x-axis. And for the intensities, I'm not going to grab all the rows, but I'm just going to grab this 22nd row. So I put 22. And then again for the columns, I'm just specifying that I want all the columns from 4 till the end. Close that bracket, close the plot bracket, hit enter. And I'll just drag the plot to the right here. And that's what the single Raman spectrum looks like. Again, we can hit the zoom in button zoom into this area. This is kind of where we're most interested. You can also hover your cursor over different points in the spectrum and it'll tell you the Raman shift, so that's the X value there, and also the intensity. So for example, this peak right here is found at 753 wave numbers. Next, let's try plotting all of the spectra from a single donor. So the very first time we plotted all the spectra, we were plotting from all the different donors, and obviously that's really messy because the spectra suffer from interdonor variability. Now, in this case, we're only going to be looking at one donor, so it should look a little bit cleaner. And yeah, so let's just pick a donor, let's say donor 12. Let's go and find donor 12, so there they are. I'm going to ignore all these polystyrene measurements. I'm just going to note that the donor 12 measurements start from row 1353, and they go all the way down to still donor 12. There. They go all the way down to row 2632. All right, so to plot all of these, we do pretty much the same thing, except we specify the rows to go from 1353 to 2632. So I'm going to type plot again. I'm going to plot shifts on the x-axis. And for the intensities, I'm going to take rows 1353 to 2653, 32, sorry. Close that bracket, close the plot bracket, hit enter. Oh, and we made a mistake here. Vectors must be of the same length. So here I only specified the rows that I wanted to take, but I forgot to mention which columns I want to take the data from. And when you don't enter rows and columns, it basically looks sequentially in all of the values in the matrix. So it'll start at the 1353rd value, and then it'll take all the values up to the 2632nd value in the matrix. So we don't want that. We actually want these to be all rows, and we want to get columns 4 till the end. So I'm just going to press up to get that code we just wrote. I'm going to adjust it a bit, add the comma here, and just specify we want columns 4 till end. So when I hit enter, we should be okay. And pull the figure to the right. And there we go. That's the Raman spectra of donor 12, all of them. So that's what that looks like. Again, these are all raw. There's tons of cosmic rays here, lots of outliers. That's something we don't need to worry about for now. Finally, another plot of interest would be to plot the means of all the different dose values for a single donor. So for example, let's go to donor 13 here. So we have all of these 0 gray measurements, a bunch of 1 gray measurements, 2 gray measurements, and 5 gray measurements. So let's try plotting the mean of all these 0 gray measurements and compare them to the mean of all the 1 gray measurements and 2 gray and 5 gray. So first of all, I'm going to go to the Home tab here, click on New Script. This will be a lot easier to work with in a script rather than the command window. I like the editor to be in the middle actually, so I'm just going to move that right here. And also the current folder, I usually like to have it on the right over here, just so I have more space in my editor. So first thing I want to do is get the data from each dose. So in this case, we're only going to be looking at donor 13. And let's say I want to get all of these 0 gray values from donor 13. So you just have to note that we're looking at rows 2673 to 2692. So I'm going to create a new variable. I'm going to call it, let's say, dose 0. I'm going to set that equal to. I'm just going to grab those spectra from the intensities variable. So the rows were 2673 to 2692. All right, and then don't forget to specify that we just want column 4 till the end, and I suppress the output. I'm going to do the same thing with dose 1 gray, 2 gray, and 5 gray. So for dose 1, all right, so if we look in our workspace, when I hit run, again, we just need to save the script somewhere. I'll just save it there. It doesn't really matter for me, but anyway, when we look in the workspace, we see that it gets updated. We have dose 0, dose 1, 2, 5. So these are basically all of the spectra we have for donor, what was it again? Donor 13, dose 0 gray, 1 gray, 2 gray, and 5 gray. So first I want to plot the mean spectrum for the 0 gray measurements. So to do that, I'm just going to type plot, shifts, and then for the y-axis, I'm actually going to take the mean of dose 0. Close the brackets, and that's all we need. Now, note that we don't have to specify which rows and which columns we want to take for dose 0 this time, and that's because we already took into account that when we created the variable. So we already specified we want these rows and we already want these columns, so we're all good. Remember that in order to plot more than one line at a time on a graph, you want to write hold on. And then we're just going to do the same thing with all of the other doses. All right. Now when we hit run, bring the figure here, we'll see that we have successfully plotted all of the mean spectra for donor 13, 0 gray, 1 gray, 2 gray, and 5 gray. If we're not sure which line is which, we can just go into the Insert tab right here and click on Legend. And it'll tell us which line corresponds to what. So the blue line corresponds to data 1, orange is data 2, yellow is data 3, purple is data 4. And in this case, data 1, 2, 3, 4 just refers to the order in which we plotted. So we first plotted dose 0. So that means data 1 is actually corresponding to dose 0 here. Data 2 corresponds to dose 1. Data 3 corresponds to dose 2. And data 4 corresponds to dose 5. That's what that looks like. We have Raman shifts on the x-axis, intensities on the y-axis, and these are all mean Raman spectra. Now there are tons of ways we can pretty up this plot. We can add titles, labels, grid lines, we can change font size, we can change the font itself, and so on. But that stuff we'll get into in another video. And that about covers everything I wanted to show in this video. So first we looked at how to actually look at the data itself. We know what the rows and columns all mean. We saw how to import the data into Matlab and also how to start plotting the data. So I hope that was helpful. I'll see you in another video.